Good morning. So today we're gonna write the mechanism of the reaction of carbonyl compounds. Okay, so let me just write the overall of this reaction. The first thing we need to do is to work under acidic conditions because the carbonyl compound is not really reactive. Well, I'm going to use two equivalents of methanol, and as I said, the first step is going to be the activation of this carbonyl compound, so I need a catalyst. So it is going to be H+, like a source of hydrogen. So the first reaction is going to be acido-basic reaction, okay? And let's try to write the products. So the first product is going to be this one, the acetal, which is not cyclic, and a water molecule. Okay, so the water molecule is eliminated, like water is eliminated using, for example, dense dark when we're working in the laboratory. So to shift the equilibrium, okay, towards the acetal. So let's try to write the mechanism. Here I'm gonna draw a carbonyl compound, a ketone. So it's an equilibrium, and the first reaction is going to be between an acid and a base. So the lone pair of the oxygen is going to be the base, and it's going to attack here the hydrogen. So we're gonna form this carbonyl, which is considered very reactive. The oxygen in this case is holding, like, is carrying a positive charge, so that makes this carbon very reactive, okay? So towards nucleophiles. So if we have a nucleophile in a medium, for example MEOH, so methanol, so the lone pair of the methanol, of the oxygen of the methanol, is going to attack this carbonyl compound, and the electrons are going to be pulled towards the oxygen. So the oxygen is going to, well, this oxygen is going to form, we're going to form OH, okay, and OH, one sec, we're going to form OHMe, so a positive charge this time on the methanol, okay? So well, after this, the next step is going to be a hydrogen shift. So a hydrogen shift, why? Because we need this group OH to leave. We need it to leave. So to form a good leaving group, we need a hydrogen shift. So I mean, like, I can grab this hydrogen and add it on this oxygen, okay? So we form, in this case, OMe, but here we form OH2+, okay? So the next step is going to be a delocalization of this lone pair. So this lone pair is going to move, it's going to move, and then we have the loss of the lone pair, of the leaving group. A water molecule is a good leaving group. So we form this carbonyl again, which is reactive, very reactive, you know, like, as you can see, a positive charge on the oxygen, and it makes it reactive. We still have another, let me just show you, we still have another molecule of methanol. We had two equivalents, so we started by two equivalents of methanol. So we're going to use another methanol, and we're going to use it to attack this carbonyl compound, the carbon of the carbonyl, and then pull electrons towards oxygen. So we form again, this one, and H+, okay? So you can just write -H+ here and delete this one, okay? And here we form the acetal, okay? This is our acetal, and some of you can say, where is the water molecule? So the water molecule is here, like this one, the loss of leaving group. This is, we can say, minus H2O. Okay, so let me just, okay, so let's get back to, yeah. So here is the mechanism of the protection of a carbonyl compound.